Hello viewers, in today's class we are going to discuss one important integral involving absolute value function, right? So here in this lecture we are going to solve this integral which is from 0 to 4 pi, and here the integrand is mod of sine x over 3, right? So let us start. Now let us first call this integral as I, right? Okay, now here what we will do, will make use of the method of substitution, right? So here see, we have sine x over 3, so the angle is x over 3, right? So let us take u is equal to x over 3, right? So here we are introducing the new variable u, which is equal to x over 3. So x is now equal to 3u, right? Now differentiating both sides with respect to u. So we have dx over du is equal to 3. The derivative of u is 1. So we have 3. So dx is equal to 3 times du, right? Okay, now see the limits. So here the limits vary from x is equal to 0 to x is equal to 4 pi, right? So when x is equal to 0, then u is obviously equal to 0 over 3, that is equal to 0. And when x is 4 pi, then u is equal to 4 pi over 3, right? Okay, so now this integral I can be written as 0 to 4 pi by 3, and here we have mod of sine u, and here we have 3 du, right? Now 3 being a constant, we can take it out outside the integral, so we have 3 times 0 to 4 pi by 3, and here we have the absolute value of sine u du, right? So now we have to integrate, or we have to find the value of this integral, right? So now to move further, what we will do here? Now here we'll make use of some trigonometry, right? Now see, we have the axis here, or the quadrants. Here we have x-axis, and this is y-axis, and this is the first quadrant, this is the second one, this is the third one, and this is the fourth one, right? Okay, now here the limits are from 0 to 4 pi by 3. So here u varies from 0 to 4 pi by 3, right? Now see, 4 pi by 3 is in radians. Now let us convert it into degrees, right? So we have 4 by 3 times 180 degrees. So this is 4 times 60 degrees. So this is 240 degrees, right? And here we have used the fact that pi radians is equal to 180 degrees, right? So here the limits vary from 0 to 240 degrees, right? Now see, this angle 240 degrees, it lies in the third quadrant, right? So here we have this angle as 240 degrees, right? So this angle 240 degrees, it falls in the third quadrant, and from the sign of trigonometric functions in different quadrants, we know that the sign of sine function is positive in the first quadrant, and second it is also positive, but in the third quadrant the sine function is negative, right? So here we have 0, here we have pi by 2 angle, here we have pi, here we have 3 pi by 2, and here we have 2 pi, right? So in the first and second quadrant the sine function is positive, right? And in the third quadrant the sine function is negative, right? So now here we'll make use of the definition of absolute value function, right? So we know that mod of sine u can be written as positive sine u when this angle u, it belongs to the interval 0 to pi, right? Because here we have the sign of sine function as positive, right? So here we have 0 to pi, and mod of sine u is negative of sine u when u belongs to this interval, that is pi to uh, 4 pi by 3. So here we have 240 degrees as 4 pi by 3. So this is 4 pi by 3. So here we can write pi to 4 pi by 3, right? So it implies that we have to divide, or we have to split this integral as a sum of two integrals, right? So here we have 3. So now we can write two integrals, I1 and I2, right? So we have 3, and I1 goes from 0 to pi, right? From 0 to pi. So here we have 0 to pi, and mod of sine u is plus sine u. So here we have sine u du, and the second integral is from pi to 4 pi by 3. So here we have pi, here we have 4 pi by 3, and here we have now negative of sine u, right? So now we have to evaluate these two simple integrals, right? So here this pi is the point where we have divided this integral as a sum of two integrals, right? Now we know that the integral of sine x is equal to negative of cos x, right? So let us first find the value of I1, right? So I1 is here we have 0 to pi sine u du. So the integral of sine u is minus of cos u, and limits are from 0 to pi, right? So now we can substitute the limits. So we have minus cos pi plus cos of 0, right? So this is minus cos pi is minus 1, cos 0 is 1. So this is 1 plus 1, that is equal to 2, right? Now I2 can be obtained as see, here we have the negative sign. So if we take this negative sign outside, then integral of sine u is minus of cos of u, right? And limits are from pi to 4 pi by 3, right? So now this negative and this negative becomes positive. So we have cos of u, and limits are from pi to 4 pi by 3, right? Now let us substitute the limits. So here we have cos 4 pi by 3 minus cos of pi, and cos 4 pi by 3 can be obtained by making some use of trigonometry. So we can now write cos 4 pi by 3 as cos pi plus pi by 3, right? So now this is cos pi plus theta, and we know that cos of pi plus theta is equal to negative of cos of theta, right? So here we have negative of cos pi by 3, and cos pi by 3 is cos 60 degrees. So this is half. So we have minus half, right? So here we have minus half, and here we have minus 1. Cos pi is equal to minus 1. So we have minus half plus 1. So this is half, right? So now the value of I1 is 2, and I2 is half, right? So now we can substitute the values of I1 and I2 here. So we have I is equal to 3 times, I1 is 2, and I2 is half, right? So this is 3 times 5 over 2, and this is 15 over 2, right? Which can also be written as 7.5, right? So the value of this integral is equal to 7.5.